Yes, my students, how are you? You are well? Okay. Okay, now see, last time you have learned about the working principle of electric motor. Now the new topic, that is induced current. Okay? This is the new topic. Now see, I am going to take an example here. See, this is a magnetic bar. You have seen that if you are having a magnet and if you are going to bring a nail close to it, it is attracted by the nail and it gets attached to it. Okay? Means it is attracted by the magnet. Okay? Now, if again you are going to bring another nail, if you are going to bring another nail close to the first one, this nail will behave like a magnet. Because why this is behaving like a magnet? Because it's get a magnetic field from this magnet, or you can say magnetic power is induced in this nail. As soon as you are going to remove this from here, what will happen? This nail will fall down. Means now this nail lose its power, magnetic power. Similar things you have seen in the class. If the teacher is present in the class, monitor is having some power. Means the student obey the instruction of monitor. As soon as the teacher leave the class, the monitor lost its power. Because the power is getting from the teacher. That is the induced power, you can say. Here also I am going to explain you that what is the induced current. I am going to remove it. I am going to write the induced current. I am going to write the definition of induced current. When a number of magnetic lines of force passing through a coil changes a current is induced in the coil. This is known as induced current. Now see, as its definition, when a number of magnetic lines of force passing through a coil changes, a current is induced in the coil. This is known as induced current. Now see here how this happened. I'm going to tell you. Suppose this is a coil, okay? If you will bring this coil close to it, now see here, the number of magnetic lines of force 1, 2, 3, 4, 5. Okay? Then what happens? A electric current will flow from the coil. And if you will bring close to means away from it, now the three magnetic lines of force is passing through coil. If you will further move it away, only one line of force is passing through coil. Means the magnetic lines of force passing through coil is changing, therefore a current will induced in this coil and it can be measured with the galvanometer. Galvanometer is an instrument which can measure the minute electric current flowing through the conductor. And now see here, this current will induce only when one of them, you can say, in relative motion, or if there is change in the magnetic lines of force passing through the coil. If you will bring the, means this can be done, the magnetic lines of force can be changed by bringing the magnet toward the coil or getting it away from the coil, or from bringing the coil towards the magnet and or getting it away from the magnet. Means they should be in relative motion. Okay. Now see here, in this figure we are having a sinusoidal coil. Sorry. Now see, in this figure we are having the solenoid and a coil. Solenoid is working as a bar magnet. The magnetic lines of force passing through coil is shown here. As soon as you will move this coil either in the forward or in the backward direction, what will happen? The number of line of force passing through the coil will change. A current will flow from the coil. That current is called the induced current. Okay. Now I am going to write one more definition similar to it, that is the Faraday's law of induction. Here it is Faraday's law of induction. Okay. See here, what is Faraday's law of induction? The same definition. Here I am going to write when the number of magnetic lines of force passing through the coil changes a current is induced in the coil, induced in the coil. This is known as Faraday's law of induction. Here it's the same definition you will see. Here the current is known as induced current and the law is called the Faraday's law of induction. Okay. Now see here in this case the electric current is induced, or you can say electric current is formed. Okay, due to the change in the magnetic lines of force. Now, for this, the direction of current and the magnetic field, there is a Fleming right hand rule that I am going to take the next topic, that is Fleming right hand rule. Now see here, you have learned about the Fleming left hand rule that tells us about the force exerted on the current carrying conductor, means the magnetic field, the electric current and force exerted on the current carrying conductor. Here the magnetic field, the direction of motion of conductor and the direction of the current, induced current. Okay, now see here, just like the left hand rule, you will see that in the right hand you stretch your thumb, index finger and the middle finger in such a way that the index finger shows the direction of magnetic field, thumb shows the direction of motion of conductor and the middle finger shows the direction of current. Okay, here the current is induced, or you can say current is produced. Okay, therefore Fleming right hand rule is used in the electric generator, because here the electric is generated due to the motion of conductor in the magnetic field. The electric current is generated. Therefore, this Fleming right hand rule is used, or its principle is used in the electric generator. Okay? Any confusion? No. Now see, I am going to write here this I am going to write the Fleming right hand rule. Here, stretch the right hand thumb index finger in such a way, that they are perpendicular to each other if the index finger shows the direction of magnetic field, the thumb shows the direction of motion of conductor, then the middle finger shows the direction of current. This is the Fleming right hand rule, and on this principle our electric generator works. Okay, therefore our next topic will be the electric generator.